Hi, I am Camille, and our group chose Mactan-Cebu International Airport as an example. The airport is known by Cebuanos as Tupahan ng Pangkalibutan or in Tagalog, Paliparang Pandaigdig ng Cebu. It was built in 1956 in the city of Lapu-Lapu on Mactan Island, a part of Metro Cebu, which serves Central Visayas region. Mactan-Cebu International Airport also took the global spotlight as it won 2 prestigious annual awards, beating other global transport stations from Singapore and Hong Kong. The design of the airport was led by Hong Kong Studios, Integrated Design Associates, with the help of the support from local firm Putti Royal and industrial designer Conic.
Engineer Nadia Paul de la Rete was born on September 18, 1962, is a Filipino civil engineer and urban planner. He was the general manager of the Mactan-Cebu International Airport, or also known as MCIA. Located in Mactan Island, Lapu-Lapu, Philippines, and the Chief Executive Officer of the Mactan International Airport Authority, or also known as MCIAE. From October 36 to 2010 and December 31, 2016. Mactan International Airport has 797 hectares, which is equivalent to 1,970 acres, and has single 3,300 meters and 10,800 feet. Mactan International Airport was built by the United States in 1965 as an emergency airport in U.S. Air Force's Strategic Command Bombers was known as Mactan Air Base. The runway is complemented by full-length taxiway that is shared with the current Mactan Air Base of the Philippines. On May 22, 2017, Mactan-Cebu International Airport, or also known as MCIAA, passed the resolution approving the proposal to start construction of the second runway, which was proposed by Representative Raul Del Mar.
The reason why we chose this architectural design is because of its terminus design that is heavily inspired by Cebuanos and Visayans culture. As you can see, the influence is not just about the architecture, but also the materials used, the splash of tropical colors, and their staff uniforms. Also because of its amazing structure that has a towering timber arches that will greet you as you land on the runway. But most importantly, its connection to mathematics. Mactan-Cebu International Airport Terminal 2 features a parabolic roof which is part of 4 conic sections, and also its concept is contextual, like a tropical grand indigenous house in the Philippines. The terminal has a high pitch roof and a low eaves to bend off the solar heat and glare, and the uppermost structure is the lightweight to withstand seismic activity and also well braced against typhoon. The bold design of airport is a celebrated landmark or a symbol of pride and showcase of best Cebu have to offer.
Parabola is the curve formed from all the points that are equidistant from the directrix, and the focus is seen in the facade of Mactan-Cebu International Airport. Features wooden parabolic roofs which symbolize ocean waves. If there are no parabolas, such an airport has not been built. This specific conic is observed in the Mactan-Cebu International Airport all around. The soaring, parabolic arches and floating glulam beams at the check-in area on the second level evoke the rich history of local expertise in boat building, woodworking, and rattan weaving. The use of floating glulam rafters evokes the memories of coconut leaf fronds swaying on the beaches. Terminal 2's curvaceous roof, supported by large Y-shaped pillars, has been likened to an inverted local boat's hull, the waves of the sea, and perhaps more potently, the woven baskets and banig that Cebu has produced for centuries. The most distinctive local design intervention can be found in the ceilings of the departure area. a system of freestanding Y-shaped parabolic pillars, X-brace rafters, and parallel floating braced beams, all made of glulam, will dominate sightlines and perspectives. Glulam was strong but pliable enough to create the terminus intricate complex of freestanding Y-shaped parabolic pillars, X-brace rafters, and parallel braced beams. Together, they lessened the number of columns, resulting in a very open internal volume. The curvilinear glulam beams comprising the underbelly of the arches are left exposed, akin to the hull of a boat. This important figure would not be all that it is had it been built any differently. It is not only for passengers to arrive and enjoy the beauty of their surroundings. The Mactan-Cebu International Airport is a symbol for Cebu, often representing all Filipino peoples. Such a history would not have been made without the magic of parabolas. Moreover, without such a wonderful sight, the International Airport of Mactan-Cebu would not be as famous. The parabola is really an important structure in the airport.
The different angles of Mactan-Cebu International Airport. The first picture, as you can see, is the inside of Mactan-Cebu International Airport. Is where you can go shopping, dine in, and you can see the lounge. The next picture is the whole Mactan-Cebu International Airport, where you can see the structures of the building and where the airplane takes off.
From this lesson, we therefore conclude that mathematics can be applied in many things. It is everywhere that it has become an inseparable piece of our lives. We realize that conic sections are so important, as it is very useful in studying geometry, which has wide applications, including their use in architectural structure. Regardless of where we are or what we are doing, math is consistently there if we notice it, such as our given example, Mactan-Cebu International Airport here in the Philippines, which shows an example of parabolic structure. The building is known for its parabolic shape roof that is reminiscent of the waves around Mactan Island. But that is not the only reason why they made a parabolic shape roof. It is also to protect and control the internal environment through a careful balance between allowing natural light to enter while simultaneously blocking excessive heat. Parabola is one of the 4 conic and conic sections. All conic sections are useful and help us in many ways. The practical application of conic sections are numerous and varied. Conics are found in architecture, physics, astronomy, and navigation. Studying conic sections help us appreciate structures around us.